I can fix on my side, or okay, sorry about that. So my name is Jean-François Denise. I am working in the Java group at Oracle. I am French, living and working in France. So today I'm going to present you the project in which I am involved since the beginning of last year. An open source project in which we are defining a framework to run server-side JavaScript on the JVM. So the name of the project is Avatar.js, a bit long name, so during this presentation I will use the name Avatar.js, shorter. Agenda of the presentation, a general introduction, presenting the project, highlight of some features of the project. How did we implement this runtime that will allow JavaScript execution? Demo time with a running demo composed of a mix of Java and JavaScript, mainly to show you some code snippets to understand how you would use Avatar.js to write your own application, and also to show you that it's running, it's for real. Finally, I will conclude with a status where we are and the benefits we think people can get by using Avatar.js. Introduction. So, as I said, this is an open source project. You can get the source and you can build Avatar.js on Mac, Linux, and Windows. There is some Git repositories there, just get the source and build it. So, as I said, we are defining a server-side JavaScript framework for the JVM. So, as one can imagine, server-side JavaScript is very different than client-side JavaScript. It's not running inside the web browser. You are writing applications that are accessing to the file system, that are starting an HTTP server, forking a process. Actually, the kind of things you are doing with Java on the server side, but using JavaScript. So there are multiple ways to do that already. And one way that is very successful and efficient is the Node way, the Node.js way to write server-side JavaScript application. So in the Avatar.js project, we have acknowledged that. And we are combining the Node programming model, the Node APIs and modular systems, the new Nazon JavaScript engine that comes with Java 8, the replacement of Rhino, and obviously the Java Platform APIs. So to summarize, you can see Avatar.js as a way to write Node.js Node applications that take benefit of the Java platforms. Okay, so the goals of the project. We are not defining a platform that look like Node. We try to define a platform that is compatible with Node. We are not there to steal Node developers and tell them, comes to Java, it's much better. Not at all, it's not our point. Our point is to take the best of both worlds and mainly take benefits of Node ecosystem. It's a way for Java developers to be able to reuse all these very nice modules and applications that are out there. Very reusable, very good piece of software there, and make this piece of software to run as unmodified as possible on top of our platform. So if your Node modules or applications have no native dependency, they should run unmodified on Avatar.js. So perhaps a good way to get a feel of what Avatar.js is, it's by looking at at an example. They're very small, but that highlights what it is. If you are familiar with Node, it's very obvious for you, but for people that are not familiar with Node, perhaps I will give a bit of information of what we can read there. So first line, we are using the require function, that is a Node API, allowing you to resolve a Node module. So in Node applications, all your scripts are well organized in modules. You have two kinds of modules. You have the core modules. You can see them as the core APIs, file system, networking, compression, security, and more. And you have all the modules you are developing, or you can install from various Node registries. So this require function is resolving the location of your modules. So a modular system, very simple to use, based on the file system, and that proves that you can organize JavaScript in a much better way than having a bunch of JS scripts all around the place. So then, Node programming model. So in Avatar.js, we are obviously compliant with the Node APIs. You will retrieve all the Node APIs on Avatar.js. And this non-blocking event-driven programming model. So nearly all APIs in Node are asynchronous. It means that don't expect a return value when calling a method. What you are doing, you are calling a method, passing to it a callback that will be called once the method you have called is done. And this method will be passed some arguments, some parameters, and the value you would have expected as a return value will be injected in this function. So this way of designing APIs, it gives a lot of flexibility to the API implementers. They are free to offload the call to a background thread or implement it synchronously. It gives you a lot of flexibility. So one thing to remember in Node or in Avatar.js, you have a single thread. The main script and all your function callbacks are called inside the main script. Inside the main thread. We are writing JavaScript, so nothing special there, just to say that you use JavaScript as your main programming language. There I am iterating my files array, and for each item in this array, I'm going to do some stuff. What I am doing, I am calling into Java APIs. So that's what Nazon is allowing us to instantiate Java classes, create Java objects, and use Java APIs. So there I am creating a Java file based on the image path in order to use image.io APIs to do some computation on my image, resize or do whatever you want. So a modular system, asynchronous programming model, Node APIs, and Java APIs. That's a summary of Avatar.js. So how do you run an application on top of Avatar.js? So you have two ways, a command line way, providing your main script, application entry point. If you have some Java classes, you want to reference from your script, obviously extend the system class path with your own classes and use the main runnable class of Avatar.js. Otherwise, you can also create Avatar.js instance and call the framework from your Java application or framework. A single class, this server class that you can run, providing some arguments, obviously the script you want to run. So there is a new project named Avatar.js. So yes, Avatar.js comes from this family of technologies. This is an example of Avatar.js being used inside another framework. The project Avatar.js is an open source project also that allows you to develop using JavaScript some server-side services on top of EE. So that's an interesting project. I'm not at all presenting Avatar EE today, but you have a lot of information on the web on java.net to get a feel. You can download source and also bundles of it. So Avatar.js is a real open source project, I wanted to say, with already real use case and real projects that are making use of us. So the main features of Avatar.js. Okay, so I think it's clear. I rewrote again running your node application of our module on top of the JVM. That's, hope it's clear. Calling Java APIs from JavaScript, it's clear too. But running node application on top of JVM brings more to node than Java APIs. It also brings the native threading. So that's something that Avatar.js is offering to node applications, the ability to start threads and run long-running or CPU-intensive computation in a dedicated thread. I will detail that a bit. We have also the ability to start multiple event loops, create multiple script context. That's also interesting when you want to densify your architecture and have multiple node application running inside the same process. So you can run multiple node applications on a single JVM process. So why multi-threading is important? When doing server-side, we are all doing that. At some point, you want to offload the main thread because you have long-running activities, you want to access to a database, you have highly intensive computation. So it's very natural to start threads there. But as I said earlier, Avatar.js are single-threaded. Avatar.js applications expect to be called from the main thread. So at some point, when you are done with your background activities, you have to call back into the main thread. And we're offering a very simple API to do that. I will show you a piece of code. So perhaps that's a nice feature of Avatar.js with Node application. If you are doing Node, when you have this kind of use case, you need to fork a process, communicate with the child process, exchange JSON. Perhaps it's a bit simpler to use threads. One thing to mention, I give the pointer at the end of the presentation, is that when doing multi-threading on top of Nazon, be aware of some guidelines you need to follow. Nothing really special, mainly be sure that the object, the JavaScript object you are sharing, global objects, are stabilized. So mainly be sure that the object you deal with in the two threads are not changing all the time. So a snippet of this background execution. In every script that run on Avatar.js, you have this __ avatar global definition that allows you to get a reference to the event loop. And with Node, as soon as there is nothing to do, the application exits. If there is no I/O activities or anything, the application will simply exit. So before to start the background computation, we advertise the event loop that we are doing something to avoid the event loop to exit. So we grab a token. Then we are calling submit on this event loop. You are allowed to create your own thread, obviously, but calling this submit method, you can take benefit of a thread pool we are using under the hood, configurable thread pool with by default a number of threads present in the pool that is 2 times the number of CPUs you have on your machine. So there, what we are doing, we are calling submit, providing a function that will be executed. The compute background will be executed in background, and when you are done with your background activities, you call again the event loop posting a callback you want to see executed in the main thread. So that's a way to resynchronize with the script thread. And you release the token to make the loop to exit if it wishes to. In this case, it will not. We have just posted something to execute. Multiple nodes in the same JVM, so really nothing special more than saying that you need to dedicate a given thread to each event loop of your node application. And each node application will have a fresh, a clean global context. So your node applications with respect to JavaScript global context will be isolated. So as I said, the advantage is it's mainly to improve or to minimize the memory used on your system. Sorry, minimize the number of processes, so more density. So how did we implement Avatar.js? As I said, the source is there. If you are interested by the project, just download it and you will see exactly how we have implemented it. So there it's much more an overview of it, obviously. So it's a mix of a bit everything. We have a Java runtime, this main runnable class that is a controller of the runtime that is using script engine API to ask Nazon to execute the main script, your application script. And in our quest to, or Graal, to be compliant with Node, we have made the choice to base implementation of asynchronous I/O implementation on the same layer as Node. Node is using UV. I'm going to give you some details on what is UV, but that this UV library that is implementing asynchronous I/O, and we have made the same. So we have developed a Java binding on top of this native library, and we are using it internally. We are doing the same also for the HTTP parser, that is also a native dependency of Node that deal with HTTP format. What to say? We have also Java, native code and GNI. The core nodes comes with a set of core modules, these core APIs, and they are running on top of Avatar.js as is, nearly unmodified. And the way we test our implementation to enforce this compatibility is by using Node unit tests. So running these tests, we try to have a low-level compatibility. So one slide on libuv. It's an abstraction that you can use on a lot of platforms. We are using it on Windows, Mac, and Linux. We are building for these three. And actually, this is foundation of Node. This is what is offering non-blocking TCP sockets, pipes, UDP, spawning of processes, all the timers. With Node, you have the ability to set timeout, to invoke, to ask for invocation of things in the future, immediately. All that is implemented with UV. So this Java binding, because it's very sensitive code, in a way it's core APIs that are parallel to Java APIs. You can access to file system, you have full power with libuv. So we have secured it with Java permissions. And where it was possible, where it makes sense, we have reused Java runtime permissions. So configuring security, you will configure your security, your policy file the same way for Java or for Avatar.js. Obviously, pipes, for example, is something that is not present in Java. So we have defined a new permission required to use these features. So we are using it, as I said, in Avatar, but because it's there in the open source project, you can use it if you want. You can use this GNI library in your application directly, outside of Avatar.js context. Demo. Sorry. Demo. So here, a mix of JavaScript and Java, Express, WebSocket, SQL image IO. So before to run it, actually running the application, running the demo will be a bit trivial. You will see it, but at least you will see that it runs. What is interesting, I think, is the code snippet I'm going to show you that can give you ideas on how you can use this framework. So the use case we have defined is a photo uploader. So this photo uploader, the use case is a user upload pictures on a website. The web will store on a database, relational database, images, and will generate thumbnails. And the server side will, thanks to WebSocket, immediately notify connected clients that new thumbnails are available. So what we want to highlight there is really creating this kind of hybrid Node Java applications. On one side, I'm using there the best of Node modules. Express, it's very famous. It's MVC Framework to develop web application. Socket.io, very famous Node modules too, very good at doing WebSocket. JAD, Node modules also, a way to write your view, write your HTML page in a very compact way. jQuery on the client side. Then Java. So there we are using GDB C APIs. So everybody knows GDB C APIs. And something that when you are using GDB C APIs, something that you already know is that these APIs are synchronous. When you ask to connect to a database, you will be stopped until the connection is established. When you execute a query to the database, you will be waiting for the query to be executed. It doesn't really fit the Node model, so we have developed for this demo a small JavaScript wrapper that transforms this API from synchronous to asynchronous. So doing so, you will see code snippets. It's natural to use them in a Node application. And image IO to rescale and generate the thumbnails. So both communication with the database and rescaling is done in a background thread. The main thread is only executing fast code that is not requiring a lot of time to execute. So an example of this GDB C layer. So there we are requiring our GDB C module. So if you are not familiar with Node, requiring a module, it's mainly providing the location of a script file that comply with some pattern on the file system. A method connect asynchronous one. You provide the URL to the database and a function that will be called once the connection is established. If you look at the parameters of this function, you will see a connection parameter that is injected once the connection is established. In this example, I am querying all images from the database. So using the connection to create a statement, this is a synchronous call because no communication with the remote server there, and ask for SQL query execution. At the end of a select star, you will get a result set. And this result set, we have defined a utility method to JavaScript array. It's much more obvious in JavaScript to use JavaScript instance than a result set. So obviously, when you are using Java APIs, at some point, you are going to transform some data structure from Java, the result set, if you know it is not that simple to use or straightforward to use, onto array of JavaScript instances that are much more natural again in a JavaScript application. So how do you, so quick overview of this GDB C module. It is exporting in Node when you want to declare the function or properties a module is exporting. You are defining them on an exports definition. Every module has this exports definition to which it can attach what it is exporting. So there are two functions connect to array, we saw them. How do you go from result set to a JavaScript object? In a result set, you have for each column the metadata where you will find the name of the column, and you can use this information to build key value pairs and create a JavaScript instance. This module defined also a connection class that is mainly wrapping the GDB C connection, Java connection class, with the methods you generally find on this connection class in Java. Create statement, prepare statement, create blob. We didn't wrap everything, just what we needed for the demo. And the statement class that is wrapping the Java statement with two asynchronous execute and execute query methods. So other example, how to use this API and save image to the database. So we have an image provider module that exposes save method, providing an image path and data and a callback that will be called when the image has been saved. It exposes this save function, so I said the image and the callback, and use the connection to prepare a statement, fill the statement with the file name, the image content, and ask the statement to execute. Execution is done asynchronous. We provide a function that in turn will call the callback that has been passed as parameter. So you see we are cascading these callbacks that are called in turn at the end of processing. Resizing an image. Again, another module that expose a single method generate thumbnail that take an image path and the dimension of the thumbnail you want to be generated, and again a callback that will be called once generation has been done. Resizing is done in a background thread, so we are defining a resize function that does the job. I will not comment on the IO API either, but at the end you can see that we are posting an event providing the callback that has been passed as parameter we want to see executed in the main thread, and some parameters that will be passed to this callback. In this example, a buffer that is a node structure filled with the content of the image. Event loop.submit resize executed in background. And the last slide to explain a bit how this demo has been developed, a simplified main application that show, first of all, we are requiring Express. So this is this MVC framework. We are requiring the HTTP module of Node and ask it to create a server, passing to it Express. And in this case, Express play the role of a request listener. Each time the server will receive a request, it calls the request listener that has been passed as parameter. Socket.io. So Socket.io, we are going to use it to advertise the remote clients that new thumbnails are there. Actually, we are doing more than that. We are also using WebSocket to advertise the uploader, the guy that is pushing its image. We are advertising him with where we are in the thumbnail generation. So we have two channels of communication with remote client there. So how do you use Socket.io? I'm requiring the module, and I'm using the listen method providing the server. It's not the server that is listening at the TCP port, it's really Socket.io listening on this server instance for new connection. Then I'm using the event emitted each time a new connection is seen by Socket.io. Socket.io is emitting a connection event. So that's a typical node, a way to subscribe to an event. On the name of the event and the callback that will be called. The callback can take parameters. In this case, it's this socket abstraction, this WebSocket abstraction, that I am going to join to the thumbnails room. Each time a new connection is established, we take the socket, put it in this thumbnails room, in which we will broadcast a new thumbnail event. Express is MVC Framework, so typically what you do, for an URL path, whatever the URL path, in this case it's the root of my website, you attach a function that will be called each time it receives a request for this path, so very typical. And what are we doing there? We are creating a function that will be called at the end of the activity. So when the image that have been uploaded are saved and thumbnail generated, we have a Socket.io API usage. So for each socket in the thumbnails room, I'm emitting a new thumbnail event, passing to it a JavaScript instance composed of a single property file name with the name of the thumbnail. So something to mention that it's perhaps not obvious when you come from Java, but this JavaScript instance that is pushed to the client in a way, how can I say that? There is a continuum between the server side and the client side. The data structure you used on the server side, you will reuse in jQuery. So instead of having to translate your Java object to JSON or to a string that you will pass on the client side, you just push a JavaScript instance, and on your client-side script, just reuse the same data structure. So I think it's a nice addition of server-side JavaScript. And finally, we are requiring the image provider module, our own module, and ask it to generate and save what the set of image we received and a callback to be called when everything is done. Last line, we listen on a TCP port for incoming request. So obviously it's simplified, but not that much. It's really the way, and I think it's a nice way to define this application. Okay, so let me go to ideally we should be multiple people, and so on this I am going to use two images. I'm going to use two windows on the same machine. So with this, I'm going to upload image, and on this one, this is the list of thumbnails that are generated. So I'm simulating two clients in a way. So let me choose some image first. Okay, and so first I am going to see a progress bar on the upload part, tracking the upload and thumbnail generation. And as soon as thumbnails are ready, this one should receive WebSocket events. So let me upload these three up. So we saw three images, so quite quick. Let me go back. I'm going this time to upload more image. You have older times Java pictures, and we'll try to be quick enough to see what's going on there. So we have this image that as soon as they are ready are pushed to all the connected clients in an efficient way. So we have played. It was very enjoyable actually to write this funny demo. It's really a funny use case, but we have also added the ability to tag image, so a user can, I have not a lot of room there, can tag an image, and what we want the connected clients. Let me, okay. We want the connected clients to be warned that a tag has been added to an image. So let's imagine that I am tagging this one as Nazorn. I will expect the connected client to receive an event and see something. So you can see in this, on the bottom of the screen, the image blinking saying that, so all that is done using WebSocket. So really we have, I was not aware of this socket IO and Express modules, but really after having developed this demonstration, I was very amazed as quick we put it in place. It was a matter of 1 day and a half. And not knowing at all these technologies. Okay, I could think you get the point of the demonstration. It's running, and we have already quite a good compatibility with major Node modules. All these modules, Socket.io, Express, we run them on top of Avatar.js. Okay, the status, where we are on benefits. So today we are compatible with a given release of Node. Node is something that is evolving continuously, so we are following the evolution of Node. Today we are compliant with 0.10.18, as I said, building on Linux, macOS, and Windows. The core modules, the file system, TLS, SSL, DNS, crypto, file system, are all running nearly unmodified. We have implemented some of them using Java APIs. So I was mentioning TLS, but actually TLS is implemented currently on top of the Java TLS implementation. Similar for zlib, that is a compression API. For this one, we are using the zip API of Java platform. So we still have some work, but very few modules are missing. Mainly domain is required for server side. The REPL is a module that you use to interact with Node in order to quickly evaluate some piece of JavaScript. So we can say that it's there. Something to mention, with Node come a nice installer. It does more than installation. It's a way to publish also your modules, a way to package them, a way to bootstrap testing. It does a lot of things. It's the NPM. So the Node package manager, we have our own Avatar.js package manager that is compliant with NPM, same features. It's not yet open source, but we are using it in the project to install modules from npm.js repository. So we are installing modules in order to evaluate our compliance with Node, our compatibility. And one nice thing is that testing is very present in this community. All the modules come generally, the major module definitely come with a long list of tests that allow us to evaluate how good we are or how bad we are with respect to compatibility. So the status of compatibility. So the number of unit tests for 10.18 is around 600. We are passing 80%. It doesn't mean that the 20% are failing. Some are failing and are obviously under investigation, and we are fixing on our side, but some of them are simply missing because we have not the required module, mainly domain that is not there. So 8%, around 10% of these unit tests are patched, are lightly patched to work on Avatar.js, mainly to change some timeout values. This test made some implicit hypothesis of the time it should take for something to happen or something to be executed, and on Avatar.js the timing is not the same. So in this long list of Node modules, I don't know if you ever go to npm.js repository, you should go. It's very well organized. You can see how many modules are referenced, are dependent upon other modules. So we took this criteria and said, okay, let's take the top 25 modules that are the most dependent and run them on top of Avatar.js. So all these modules come with a lot of testing framework. It's incredible how many testing framework you will find in the Node ecosystem. In Java, let's say you have 5 ways to do unit testing. In Node, you have 50. So we discovered that we had to run much more Node modules on top of Avatar.js than we thought at first. But it was a nice experience that is not over. We continue to add tests to our suites. And so the top 25 are running as is. Some of them have to be patched because JavaScript engines are not implementing the JavaScript specification exactly the same way. So, for example, currently Nazorn is not supporting the const keyword that Google V8 is supporting, so we have to replace const by var as a temporary hack. Sometimes we have some functions that are declared underneath, and I'm not a JavaScript expert, but people argue saying that no, this function in this special case can't be located there, it should be defined before it is used. So very advanced use case that require some localized patching. But if JavaScript one day becomes well-defined and everybody agrees, we shouldn't have a single line of patch. So the benefits, we think, obviously you will have your own idea on it, but the benefits you can find at using Avatar.js. You get it, it's not running on the JVM. And I think one point is that security. With Avatar.js, your code base are script. So for each script, you can associate a set of permissions. So it's a way to secure Node applications with Java security model. There we are speaking about running on top of the JVM. So it means ability to use all the tooling, all the monitoring and management tooling, profiling tooling you find with Java. So JConsole, the older console, but JVisual using JMX to instrument your Node applications. This new fly recorder, Java fly recorder, using the mission control. So a long list of tools to help you diagnose memory consumption, CPU activity, mainly to profile your application. And I'm pretty sure I would have the question about debugging. So that's an important subject. And today, there is no debugging tool at the level of a product. But if you download the latest development build of NetBeans that will come, NetBeans 8, there is a new support that is coming where you can set a breakpoint in JavaScript, step into Java, set breakpoint in Java, and so on. So you get it, and really, it's just coming. It's something new. They are just adding this support now, and I can tell you that it will be, when it will work well, it will be a very good feature, because it's this kind of hybrid applications without any debugging support, completely asynchronous with all these callbacks, all these events coming at once. Without any debugging tool, we had quite a lot of difficulties but it's coming. So you will get a decent debugger thanks to to NetBeans. As we saw, when you want to complement what Node is not offering, you can switch to use Java APIs. And the current runtime is small, it's less than 2 megabytes. We have worked at using only the compact one profile. So we should be able to run Avatar.js or Avatar.js application on embedded system. It has not been tested nor prototyped yet, but it seems that it can be a good candidate. Some resources to end this talk. 2 projects open source, so project Avatar.js is what I speak about today. This generic framework that you can use in multiple contexts. The project Avatar, this EE project, also on java.net. And the Nazon blog. A lot of interesting information there. Code snippet to do JavaFX with JavaScript. There is a lot of information, and one of these is the second link I give there. It is a thread safety article. So a must-read definitely for, I would say, Avatar.js, but Nazon in general. And if you are new to scripting on the JVM, this article at the end is a very good introduction to discover how to do JavaScript on the JVM. Okay, so thank you for attending this last DevOps presentation. I hope it was not too boring. If you have any questions that I can answer, I will be happy to do so. Thank you.
How did you make JDB C asynchronous?
So I have to say what this person said. So the question is, how did we do to make GDB C asynchronous? We are using a dedicated thread, a background thread, in which we are offloading. For example, connection is done in a background thread. And once this thread is done, it will post an event with the established connection onto the main thread. So that's really playing with a background thread in which we offload all this take long time kind of stuff. Does it answer your question? Yes, that's a very good question. Actually, so the question is, why did we choose to use libuv instead of async.io library that is present in Java? Actually, we started, obviously, by using asynchronous I/O of Java. And we have experienced some timing and scheduling issues. So it was working. We were able to have something that was similar to what Node is offering. But we never managed to have the compliance we have today with libuv. We were able to implement 100% of features, and it's not true because, for example, pipe or access to some, I didn't speak about all the APIs, but you have the ability, for example, in Node to change the current working directory. That's very simple stuff, but in Java you can't do it. There is some hack to do it, but you never do it in a way that works. So we started to add a piece of native access because we had some missing features, and realizing that we never managed to get compliance with NIO, we decided to move to libuv. I think yes.
How would you say the performance compares with native Node.js or a single-threaded application?
Okay, so that's a very good question. So in terms of performance, how do we compare with Node? So if you are okay, so first we how to say, we are not competing on performance first because this is not our key point. We are more an integration framework with Java and JavaScript. But for now, we are definitely slower. For simple example, we can, in some time we can observe good numbers, but generally we are observing 2 to 3 times slower than Node. I don't want to claim performance numbers because we are doing some benchmarking, but it's not very formal. It's what you were asking for, a simple test case that does open a file and read it continuously for 60 seconds. And we are observing that we are slower. We will get definitely better because we can gain performance at all the levels. We take benefit of the JVM optimization. We take benefit of Nazorm script engine optimization, and so on. So we will get better, but today we are slower.
How much of the performance problem is using JNI?
It has not been measured, but yes, good point. We know that JNI is impacting our performance. It has not been measured, but we definitely acknowledge the fact that it has an impact. Yes?
When do you plan to publish this for the package manager, and is it going to be compatible with NPM and Power, for example?
And sorry, what is the end?
With Power, is it going to be compatible with Power?
Okay, perhaps I will repeat the first part of your question. Perhaps you can come to me and explain me what is the second part. I don't get it. But I really don't know when the APM will be open source. I can't comment. I don't know. It's more the release engineering people that and it is the goal is to have it compliant with NPM completely. To be able to download your application from npm.js registry and just run it. So yes, compatible as much as we can, and it's already the case. We are installing our module with APM, but I can't comment on a release date. Okay, thank you very much.